Okay, we're going to do a climate control board repair. Hopefully we got a decent video of it. It's going to be a little shaky, but what are you going to do? So, your generic, regular, accurate NSX climate control board. So first thing first, take off the 13 of the failure-prone electrolytic capacitors. Ooh, be careful. Can't get a little ham-handed here. Okay. Definitely done too many of these, so don't spending a lot of time on them. Just get right to it. Ooh. So, this board's in not too bad a shape. Definitely seen much worse. Okay. And one more. Okay. So, need to loosen up all the faster leakage corrosion. Doesn't do. Make sure we get all the bad spots repaired. Nothing too much here. Oh, there's a spot. Got a really nice big spot here. Leakage from the capacitors climbs up underneath the solder mask on the board. And it's kind of a mess. So definitely want to get all those spots open up so I can get them all cleaned out. So the repair is long term. Or is it forever? Whichever one you want to look at. A little bit of trimming to do here. All right. There's step one. I'm going to pause it here and clean up. Okay, well, I think we're back on, right? Oh yeah, there's red light. So, get it all cleaned up here. This capacitor leakage is a caustic, so it's, excuse my arm, so it is a little, it does corrode the board, so make some quick checks here. Make sure I find all the bad spots. Definitely have a pretty good idea where to look. Definitely gonna make some repairs, even though the board's got no obvious damage to it. No broken traces, but definitely there's been several of these traces that have been compromised. So we want to make sure they are good for the long term. Okay, soldering iron's on. Remove all the old, pull the solder out of the old holes here. Kind of adding solder when you're desoldering is kind of counterintuitive, but a little fresh solder really helps with heat transfer. So definitely want to get enough heat in here. Got the Metcal soldering station, so I've been using for years. Some people like them, some people don't. Works good for me, so this is definitely done a lot of these circuit boards over the years, so it's does what it needs to do. Can't complain. Definitely goes pretty quick. And they're not in bad shape like this one. Get some ones that are in much worse shape, and they can be very time consuming. All right. Some of them don't want to come out first try. We want to get the holes all nice and cleaned out. So we have to fight getting the new capacitors in place. Adjustment on the camera here. I got you. Hopefully, getting a reasonable view of this. It looks pretty good, but using the GoPro, you don't have much of a viewfinder. It's kind of a point and shoot. You're pointing to where you want to go, and hopefully it comes out good. That's a solder everywhere. Okay. Some of them desolder easy, some of them take a little more persuading. I usually work from the top side of the board. Most people can work from the bottom side. I like doing the top side, and then take the solder off on the top, and then put the resolder from the bottom. Both ways works, but all right. Okay. That wire did not want to, piece of that lead did not want to come out of there. All right, there we go. How are we doing here so far? A couple more spots here to touch up. Pull the solder out of the holes. Okay, third time's a charm. There it goes. When there's a lot of corrosion and stuff, it's hard to get good heat transfer to the board to get the old solder melted. So it takes a few more tries, a little more effort. And then you rub the solder around and fill the hole back up again. So, fortunately, we can just pull the solder out again. Okay. Come on. Yep. Still got stuff going on there. Come on. There. least. Come on. Yeah, a little bit of corrosion there. Soften it. There it is. Plus that's the negative side, so there's a lot more copper. And the ground plane of the board, so a lot more copper there to suck up the heat. Okay, come on. Alright, so 6 more through holes to pull the solder out of. And one more here. There's 13 capacitors, 13 electrolytic capacitors, so out of 13, that means 26 holes to clear out. Oops, oh, it seems like it didn't need cleared out. Okay, getting there. I think over the years I've done over a couple thousand of these boards, so definitely if you do enough of them, it gets to be a little routine. But yeah. They all got to be done right. Or is it wrong? These all of these fail, so they all need repair at some point in their lives or replacement. Right now, the Acura list on these is about $800, so repair is definitely economical over the cost of buying a new one, and as with a lot of NSX parts, not sure how long these are going to be available. Solder sucker's getting a little full of solder. Just get a lot of mileage out of a solder sucker, but I can go through a couple a year. Go through about a pound of solder a year. So, all right, everything's cleaned out. I make like your neighborhood dentist and do a little scraping. No drilling and filling, but scraping. Looks okay. Just checking here to make sure that how extensive the corrosion is from the capacitor leakage, and see if I have to make any repairs. Pretty good so far here. Doesn't need a wire. Like I mentioned, there's some of these that require a lot of repairs to the board. There's a lot of corrosion damage, a lot of damage traces. This one's surprisingly not in that bad a shape, so we're going to have a lot to do, a lot of circuit board repairs to do, if any. damages the traces, so I'm gonna make sure I check them all, make sure all the connections are good yet. Try not to damage any of the connections. Scrape them like that. I mean, you gotta be a little careful. Oh, that was alright yet, I think. When in doubt, pull out the meter and measure it. I'll just use beep test on my flukes, so from there to there. It's visibly looks okay, and it electrically measures good, so I'm gonna call it good. Sometimes I gotta put it up to the light and check. See if I can see if there's a damaged trace. So let's check this one. That one's alright. This one to here. Go, come on. Second one, okay. Check it, you gotta check it to the right point. Okay. We're golden. So, now comes my favorite part, putting it back together. So, I replace with all the same values, except maybe one, because some of the values are getting a little more difficult to get. As with standard with capacitors, as you go, you always want to get the capacitor rating, so I have them rating in microfarads, the same, and at least the same voltage rating. You can go up on the voltage rating without hurting anything, without causing any issues. You don't want to put in less capacitance, you don't want to put in more capacitance, you don't want to put in less voltage. The voltage rating. Capacitors are rated to work at a certain voltage, and if you over voltage them, they can be unhappy and blow up. And with electrolytics, you definitely don't want to put them in backwards, because when you put them in backwards, they fail catastrophically. They split open and smoke comes out. It's pretty cool. So obviously you gotta pay attention to the orientation of the capacitors. Make sure they're the positive and negative ends of the capacitors are positive and negative leads of the capacitors are in the right holes. These boards they are all marked to the polarity to the capacitors. All marked at correct polarity, and the capacitor is marked, the board is marked, but sometimes I do a little touch up on the top side here to make sure they're not going in the air. Good electrical connections. So the boards are marked. Usually the negative side or the positive side marked. Well, this one's it's marked negative and the positive marked. And all the capacitors, of course, are marked minus on the minus band. The minus lead is shorter, and the other side be positive. So as long as you put the longer lead, let's put this one in first. The longer lead goes in the positive, and the shorter lead goes to the negative side. And most circuit boards are lined up where all the capacitors are all facing the same direction. If you notice that all the negatives are on this on the upside, which makes it a little more helpful. So I mean, if the marks get obliterated because of the leakage damage or overzealous scraping, or whatever, they're not sure. Usually all are oriented the same way. Not all the time, but this board is. This circuit board is. So this is. The bigger the, you don't need the bigger blob doesn't make a better job of it, as is said by some people. Enough is enough. I am using that terrible lead-free solder, so which is what this board was built with. So this is also a no clean flux formulation, so you can see it doesn't leave those big puddles of brown stuff like a rosin core solder would. So works very well. You see by 1 pound spools, so I go through a fair amount of it. Let's see. Definitely go through a lot of capacitors. Throw one or two or three in place, flip it over, solder them, clip them off, check the top side. Enough solder on. Make sure you give it a little time for the solder to flow nicely. Sometimes it doesn't flow all the way through real nice. It'd be fine. It's usually fine, but I usually have a little touch up on the other side. Okay, well, we're clipping right along now. Two of those. Yeah, it's not a horrible process. Obviously, this board is in really not in bad shape at all. So. Sometimes I have quite a bit of time spent repairing those traces that get all damaged, and some of the boards look pretty bad. There's a lot of time cleaning everything up and fixing all the bad traces. And usually put wires from through point to through point. I don't try and just run along the trace and just kind of solder it on. Try and go point to point and replace. So the trace is pretty much bypassed. It's fine. You can kind of see some of these fine traces down in here are very minuscule for me to clean it off and try and solder a little wire on there. It's not impossible, but it's way more fun than I really want to have. So, I'll go point to point. Oh. Yeah. Somebody's hit me on the Facebook Messenger. Okay, that looks good. I scraped all the solder mask off that trace, so I'm try and put a little solder on that trace just to back it up a little bit. Where's this one go? 330 by 10. Like I said, I've done quite a few of these, so don't have to look up. We've got all the locations and all the sizes all memorized after lots of repetition. So definitely go together pretty quick. Like I said, this board doesn't have any big problems, but that's subject to change once I put it on the test fixture too. I normally go right into repairing them. Not very often do I pre-test the boards before I work on them. I usually tear them down and clean them up and go through and fix the stuff that I can see, and then test them. And 95% of the time, 90% of the time, it's good. Once in a while I miss something, I've got to go back and figure out what the problem is. So these boards that look relatively good are kind of scary because who or what got into it. There might be something damaged, something blown up. The light back feeding power into the sensor lines and helping me out with that. When it stops working, they do all kinds of stuff trying to figure out why it doesn't work. So they're pretty durable, they're pretty well built, well engineered, and they take a lot of abuse, but feeding 12 volts back into a 5-volt signal line is usually not the best for it. Alright, well, I'm going to stop you here and take you back to the test fixture and see if... Alright, we're back at the board here, my test fixture here, so plug it in, and test display unit, so hopefully we'll see what happens here. Light it up. Alright, so it does look like it's functional. At least it lit up. Check to see if the display lights work. So I go minimum temperature. I wait for the fan to come on. Maximum temperature. Standard test procedure. Oops. So this display's been around the block a couple times. So the connections aren't the greatest. Alright. So saw the, there we go. So I'm going to go to maximum temperature. I'm looking for the water valve to open. This is the vent opening and closing. Now it'll close. One notch off of that, it'll be closed. Making sure all the modes are working. The mode motor's down here, the vent motor's here. The mix motor's actually underneath the unit. This is actually the compressor run signal, so as you can see, surprisingly or not surprisingly, the air conditioning compressor runs a lot. Oh, come on. I think that's just a bad connection in my display here. And then I think, hope you can see this. Oh, I said this display's been used on about probably over 1,000 things, so the connectors are getting a little tired. Bring it down a little more. There we go. Oops. So test procedure, I think you've seen that before. Whoa, come on. So auto and off. So we have no errors. Create an error. And you can see I disconnected the mode motor. And now we have on, which is AC on. Open position signal circuit for mode control motor or mode door stuck. So, alright. I'm confident that's a good board. So that's the extent of the process. Disconnect from my test fixture here. Cut that off. Cut that off. And of course I'm going to autograph it like every board I do. Okay. That's a winner. Get this this packaged up, get it sent back.